Hi everyone, welcome back to AI Incarnation. Today I'm excited to show you how to run DeepSeek-R1 model locally using Ollama. We are going to set up the model on a machine and interact with it via the command line. So you can see the first hand how this cost-efficient open source reasoning model works. Let's jump right in. DeepSeek-R1 is a flagship reasoning model developed by DeepSeek, a Chinese AI startup that's making waves by achieving top-tier performance at fraction of cost of other models. Today, we are focusing on the distilled 1.5 billion variant DeepSeek R1 1.5B. This smaller, high-efficient version is perfect for local testing and integration into lightweight applications. It still leverages advanced chain of thought reasoning, but it's optimized to run on less demanding hardware. Before we run this model, make sure you have Ollama installed on your machine. If you haven't installed it yet, head over to ollama.com and follow the instructions for your OS. Now let's verify the installation. So I'll open my terminal. To verify the Ollama version, we will simply use the command as ollama-v. Ollama version is 0.5.11. So we know that Ollama is installed on our machine. The next step would be to get the DeepSeek R1 model, that is 1.5 billion model, and we need to pull it from the Ollama repository. We have confirmed that Ollama is installed on our machine. Now we will go to the models part and select DeepSeek R1. Here we will select 1.5 billion model, that is only 1.1 GB. We will go to the command prompt and make sure that we pull this model. Ollama pull DeepSeek R1 1.5B. To check a list of models that are already available, you can simply type the command Ollama list. This will show you all the models that are currently on your machine. And for this demo, we will be using DeepSeek R1 1.5B. To run this model, we'll simply select Ollama run. Then we will give the model name, that is DeepSeek R1 1.5B, and we will hit enter. As you can see that we got a prompt, send a message or / for help. So the very first thing that we will do is that we will try to say a greeting message that will be hi. As you can see that the 1.5 billion model is currently working on a system, and this is the think part that the model has done, and it has responded with hello, how can I assist you today? This was just a simple message, so we'll try with some different messages. So we'll try to ask a simple question like, the speed of the model is quite fast. I'm currently running this model on 16 gigabytes of RAM, and the output is quite fast. So we just greeted the model with hi, and then we follow up with a question like, what is LangChain? You will see the model generates a response. One cool feature of DeepSeek R1 is that it is having a chain of thought reasoning. It shows you the part of internal thinking process before it gives you the final answer. So when we asked a question like, what is LangChain? It responded by thinking in background on the question that is asked by the user, and then it will give us the answer, that is, the LangChain is an AI framework that allows developers to deploy and use generative AI models in production environments. So it gave you the exact answer that we want after thinking on this particular question that we have asked. Okay, let's do an interactive demo. I'm going to ask the model a few questions like, explain step by step how gradient descent works. As you can see, the question asked was explain step by step how gradient descent works. So it started thinking on it and it said, alright, so I need to explain gradient descent in a clear and step-by-step manner. Let me start by understanding what gradient descent is all about. So it started thinking on it, the gradient descent and optimization part, and it break it down in some key concepts. For example, the loss function, the parameter, the gradient, and the learning rate. Next, it think about how gradient descent works in practice. Initialization, compute gradients, update parameters, then the parameter equation, iteration on it, and again it think about it. But wait, why do we make multiple iterations? Is it possible to reach the minimum quickly? Well, that depends on several factors. So it is explaining about the factors behind it, the loss function, the complex loss function, and it's thinking about more examples where gradient descent works. So let's say grid search or cross validation, large data sets, nonlinear problems. We can see that it has given us a pretty good answer. Let's ask about a Python question now. So we'll ask something related to coding, that is write a Python code for binary. As you can see that it's responding quite good. So I asked write a Python code for binary search. So it started thinking on it. It's thinking step by step on the question that is asked by the user. And this is the chain of thought for this particular model. Since this is a 1.5 billion model, it's performing pretty good, I would say. And it has given you an answer like first binary search is used to find the item in a sorted list. It works repeatedly, dividing the list into halves until you find the target element. Each step roughly cuts down the search space by half. That's a good explanation of binary search, and it has implemented it and explained you the step by step how it will be implemented. Similarly, it has given you an example also, like this is the list and we are looking for number 3. The function should return 2 since the index start at 0. So iteration 1, this is the middle part, how it works. Then it has given you the example 2, iteration 1, 2, 3, loops end, the number was not found. And here the thinking part got completed and it has given you the complete Python code itself. Also, it has given you an explanation part that the function binary search takes 3 parameters, left, right, and the number that you want to search for. It initializes a while loop and continues as long as left is less than or equals to right. So you can see that it has given you clear explanation on the concept behind the binary search. Before we wrap up, here are some quick troubleshooting tips and best practices. First, check API and model name. Make sure that you're running the correct model. So these are the models that are currently on our system and I'm using DeepSeek-R1. So make sure that you are copying this model name correctly to use this model. To run this, you know the command is Ollama run the model name. If you are making any mistake in the model name, for example, I'll remove 1.5 and I'll just keep it 1. Error. The model name does not exist or the file name does not exist. You can see the error as full model manifest file does not exist. There is a model called as DeepSeek-R1:1. Next is the parameter adjustment. So there are a few parameters that you can adjust. For example, temperature, the max number of tokens. You can experiment with all these parameters to see how the model works or model behaves based on these parameters. Feel free to experiment with the temperature and maximum number of tokens to see how they affect the output. Next is system resources. Since this is a digital model, it is designed to run efficiently on local hardware. However, you experience delay, check your system resource usage. Next is chain of thought prompts. For more complex queries, you can explicitly instruct the model by including prompts like please explain your thought process step by step. This will help to maximize the benefit of its chain of thought reasoning. And that's it. Today we have set up the DeepSeek-R1 1.5 billion model locally using Ollama. and built an interactive session through the terminal. You have seen how easy it is to leverage this advanced reasoning model for everything from theoretical questions to coding challenges. If you found this video helpful, please give it a thumbs up, subscribe to AI Incarnation, and click the notification bell icon so that you will never miss an update. Drop any questions or project ideas in the comments. Thank you for watching and see you in the next video.